Hey, hello everybody, this is Program123 again, and today we're going to solve this problem named Decayed Bridges. It is problem D of Coder Beginner Contest 120. It basically says that there are n island and n bridges, and the ith bridge connects 8th bridge, 8th island and b8th island. And initially we can travel between any two islands using some of these bridges. However, a survey show that these bridges will collapse because of edgings in the order from the first bridge to the end bridge. So basically they are gonna give us a list of bridges and they are gonna collapse in order, and we're gonna have n islands and n bridges, at most 10 at 5 both, and all pairs of island will be distinct, and we have bidirectional roads between each pair of islands. So they are asking us for the inconvenience just after the ith bridge collapses, and the inconvenience is the number of pairs of islands that are no longer connected by any path. In this case, when the first bridge collapses, nothing happens because I can travel freely between 1 and 2, that are the ones that are not connected anymore. I can travel between 1 and 2 using going to island number 3 using the bridge 1, 2, 3, and then I go from island 3 to island 2 using this bridge, so nothing happens. And the same for this second bridge. But for the third bridge, we have that we can no longer travel between 2 and 1, 2 and 4, 3 and 1, and 3 and 4. So we have 4 pairs of islands that we can no longer travel between. So basically that's the problem. We have to answer the inconvenience. We have to output the inconvenience when the ith bridge just collapses. Okay, so what are we going to do? One may approach this problem by multiplication principle, and that's okay because we need multiplication principle in order to know how many nodes are disconnected. But how are we going to do that? I can select an edge and compute the size of the subgraph at both of its endpoints, but that doesn't help a lot because we gotta make DFS in order to compute that. In order to compute the number of nodes that every subgraph has, and we don't actually know where to go. I mean, if you have 2 endpoints of an edge, you will never have a way to know which graph is shorter. I mean, which graph is smaller. So you cannot actually go to the smaller graph to count the number of nodes in the smaller graph and subtract it from the total nodes of the bigger graph to get the size of both subgraphs. You cannot do that. I mean, you cannot actually know which subgraph is smaller. There is no way to know that. And in the worst case, we are gonna be doing DFS on a subgraph that has n-1 nodes, then n-2 nodes, and then n-3 nodes, and so on. So we get a complexity of n squared, and that doesn't help us because n is gonna be as big as 10 to the power of 5, and m is going to be as big as 10 to the power of 5. So that doesn't help us. So we gotta think that in another way. Basically, to solve this problem, we just have to think backwards. Okay, what happens when all bridges collapses? Well, all pairs of islands are not connected, and what is that inconvenience? Well, it is actually nc2, n combined with 2. In this case, n combined with 2 is 4 times 3, which is 12, over 2 is equal 6, and that's it. That's the last number that we're going to output always. As you can see here, we have 6, that is the number of nodes in the graph, and 6 times 5 divided by 2 is equal 15, which is the last output, the last line of output that we output. So, but what happens when the last bridge is still alive? Well, it happens that 4 and 5 are connected. So this equals to the sum that we have previously computed, n combined with 2 minus the number of nodes that this edge is going to join. In this case, 4 and 5, it just joins 2 nodes, so we have 1 pair less. Okay, so you see, from 15 we went to 14. When this edge was still alive, then we have the subgraph that included 4 has 4 and 5. I mean, 4 was already joined with 5 and 3 was along, so we have an edge that joins a subgraph with 2 nodes and another subgraph with just 1 node. So we have now 2 more pairs of nodes connected. That is multiplication principle. So you see, we went from 14 to 12. Basically, we just subtracted the number of nodes that are now connected. And what happens when you connect 5 and 6? Well, 5 has a size of 3 and 6 have a size of 1. So you are joining 3 pairs of nodes. So 12 minus 3 equals 9. And so that's the way that we can compute that, and we can actually do that way backwardly using union find disjoint sets. So basically, we are processing this queries offline. We read the list of bridges and we are going to say, well, what happens when the last bridge collapses? Then what happens when the one before the last bridge collapses, and so on. And we store those answers, and then we just print the vector reversed. So let's see the code for that. Okay, so for this code, we're going to have LL defined as long, VI is a vector of integers, BL is a vector of long, and II is a pair of longs, and VII is a vector of pair of long. Okay, so we actually don't need this function. We're going to have this global variable, which is the one that we're going to be operating, and you're gonna see how. Well, at first we read L and M, and we read the list of edges, and we are going to iterate backwardly from n-1 to 1. We actually don't get to 0. So basically, we create this structure of union find, and at first we compute the n combined with 2 and push that to our vector of answer, to our answer vector, because that is always last line of output that we're going to have. And at the end, we reverse this vector of answer so that we get the answers in order. Okay, so for each iteration of this cycle, we're going to merge those pair of vertices, and we are going to push the current value of sum. Okay, so how is sum going to change? Well, we have find set. We have the function find set to find the node that represents the group that some vertex u is in. Okay, so that we don't actually need some more explanation about find set, but about merge. Okay, so we're going to find set of UMV, and if they belong to the same set, then we return that. We don't do anything at all. But if they were in different sets, we are going to subtract from sum the size of the subgraph that started with x, and the size of the subgraph that started with y. Why? Multiplication principles. the nodes on this subgraph and the nodes on this other subgraph are now joined. And how many pairs were joined? Well, actually, this multiplication. And that's it. That's everything we have to do for this code. Now, after that, we just reverse our vector of answers and print all answers. How does this work? Well, we compile it, and now we're gonna copy this input, and you see we get 8, 9, 12, 14, and 15. That's the answer that we require. Let's see for the first sample input. Okay, this is 00456. 00456. That's the answer we wanted. So basically that's the algorithm for this task. Thank you for watching this video, and share with those who need it. Remember to stay safe at home. Happy to see you again. I hope this video was useful for you, and thanks a lot. Please subscribe, share, and bye bye.